Hey everyone, today I want to talk to you about equivalent fractions. As we begin to transition into adding and subtracting mixed numbers and fractions with unlike denominators, kind of having a wrap on understanding the equivalent fraction is going to be a huge part of what we do. So with our equivalent fraction, first let's kind of define it and gain an understanding of what it is. So the equivalent fraction is where we can take a fraction and change the numbers, but the value stays the same. So for example, if I have 1/2, which is one of the more popular fractions, I can say that 1/2 is also the same as 2/4. And just to help you visually kind of understand this, let me show you a picture here. And I'm going to try my best. Here's my circle. And so for it to be 1/2, I would take the circle and cut it in half, and I'm going to shade just half of it. So that represents what it would be for 1/2. Now I could take that instead of, because what we learned, one of the things we learned in introducing ourselves to fractions is our denominator are the total number of parts, right? And then our numerator is kind of what and I like to say it's just what we have. So we have, of the two parts, we only have one of the two parts. We can take, and if you look at the 2/4, we can take, what if we had 4 parts, and I'm going to use yellow here to kind of, so we can see on our, what if I cut this in half going from left to right? Well, all of a sudden, I now have 1, 2, 3, 4 parts. But if you'll notice, the shaded area did not change. I still have 2 of the 4. So my value doesn't change, only my numbers do. So what I want to show you is just a strategy to help you find equivalent fractions so that it'll help us once we start adding. And I'll show you that in the days to come. So I'm going to erase this. And I want to set up and just show you how we're going to find equivalent fractions. So given a fraction, let's say 2/3. What I want to do to find the equivalent fractions of 2/3 is the first thing I want to do, and let's just say I'm going to find 4 equivalent fractions to 2/3. So I'm going to just set up equal signs and then go ahead and put my line that'll be between my fraction, because what I'll essentially do is I'm going to put a number here and a number here. But I'm going to get to that in just a second. I want to set up first. And so I'm going to set up where I have 4 fractions. So I'm going to run out 4. And watch what I'm going to do. I'm going to skip count by the numerator or the denominator. So I'm just going to skip count by 2's and fill in my numerators. So I would go 2, 4, 6, 8, 10. Then I'm going to go to the denominator, and I'm going to skip count by the denominator of 3. 3, 6, 9, 12, and 15. Now what I have done, if I've skip counted correctly, which I have, I now have 5 fractions that, while they all use different numbers in the numerators and denominators, all 5 of those fractions have equal value. Because I skip counted or multiplied, my multipliers were the same. And then I'll show you kind of what's going on with the multiplication. Is with 2/3, I multiplied both by 2. With 4, 6, I multiplied 2/3, the numerator and the denominator, by 2. We know this because 2 times 2 is 4, and then 2 times 3 is 6. And likewise, if you come out to 6/9, the multiplier was 3. I know this because 2 times 3 is 6, and 3 times 3 is 9. And I can continue to walk that out. This multiplier is 4 because 2 times 4 is 8, and 3 times 4 is 12. And this multiplier, meaning when I say multipliers, what I'm multiplying the original fractions, numerators and denominators by to get the new numerator denominator. So 2 times 2 is 10, and then 3 times 5 is 15. So when you see the multiplier, that's what I'm talking about when we're looking at that. So my strategy was to simply skip count, but the math behind that is that I am multiplying both the top and bottom by the same number, which is, in each case, 2, 3, 4, and so forth, okay? So let's take a look at another example here. We're going to take a look at 4/5. And if we're asked to, create, which you will be on your assignment, you'll be asked, hey, can you make 4 equivalent fractions to a given fraction. So what we're going to do is we're going to write the original fraction down. Then I'm going to set up as if I'm going to make the fractions. And then I'm going to skip count. So I'm going to start with, and it doesn't matter if you start with the numerator or denominator. In the first example, I started with the numerator. In this example, I'll start with the denominator. And I'm going to go, okay, 5, 10, 15, 20, 25. Then I'll go to the numerator, and I'm going to skip count the same. 4, 8, 12, 16, 20. And I've simply filled in, and I know that all 4 of the fractions I created from 8 tenths, 12 15th, 16 20th, 20 25ths are all equivalent or the same value as our original fraction of 4 fifths. Okay, so again, that process was that I just wrote the original down, drew my lines to create a fraction. I skip count numerator, and then I skip count the denominator. I would like to show you one other way that we could look at these. And what I'm going to do this time, I'm going to say, well, what if I have 2 fifths and I have 15 here, and then I'm missing something that would go here. A number should go here, but what if it's not there? So this is where I'm going to use the multiplier. And what I'm going to do with this particular question is I need to first go and look, which do I have both of? Do I have both numerators or do I have both denominators? We're going to notice that in this particular equation is what it would be. I have both denominators because we're missing the numerator here on the top. So let's start with what we have. I'm going to have to now look at 5 and 15. And you have to ask yourself, what is 5 multiplied by to become 15? 5 times what? It would be 5 times question mark equals 15. We have to first solve that. Whatever we can multiply 5 by to become 15, that's our multiplier. Well, I know that 5 times 3 is 15. 3 is my multiplier. So if it's equivalent, that means equal. Whatever I do to the bottom, I have to do to the top. So if my multiplier on the bottom is times 3, which it is, that makes that true, I just want to multiply 2 times 3. And now I can get rid of that question mark because I now know what it is. And that would be 6 over 15, and I've completed that. Again, the approach here is that you need to find what the multiplier is, and then whatever you do to the bottom, do to the top, because it is an equivalent fraction or equal. Whatever we do to the denominators, we need to do to the numerators. So that's a quick look at equivalent fractions. If you have any questions, let me know. Take care, and I'll talk to you soon.